Good evening, everyone. I hope that you guys had a great day at school and ready to learn a little more chemistry today. So today we're going to talk about how to name acids. Now, what we have already been doing is naming ionic compounds. And so when you hear the word ionic, you should be thinking that it is a metal bonded to a nonmetal. You have a cation that's positive and an anion that's negative, and it meant that it's transferring electrons. Now we're going to take a look at how to name acids. And the first way to identify the acids is that they all begin with hydrogen. Okay, so let's see. I am recording this at home, so I'm using a little bit different device. So you might have to bear with me a couple of times here as I'm choosing my pen colors and trying to move around the screen. Okay, so acids are compounds that produce hydrogen ions. So like I said, they will all begin with hydrogen, and they are always going to be dissolved in water. So you can see this begins with hydrogen. This is hydrochloric acid, and we're going to learn how to name this. And when you dissolve it in water, it always ionizes, it's called, and it breaks apart. You don't need to worry about that right now. We're just going to work on naming. Okay, you have this on your cation anion sheet. I just took a little screen capture of part of your gold sheet. So make sure you look where this is. And this is what you're going to be using when you are naming your acids. So we just said that the acid starts with a hydrogen cation, and the name depends on the name of the anion, which is the last name. So you have to take a look at all these different ways. If the anion ends in "ide," we say it's hydrorootic acid, hydrochloric acid, for instance. And if it ends in "ate," it's the root with the "ic." Anion ends in "ite," and then we have OUS ending. Per-ate, it's per-ic. And an anion with a hypoite, it's hyporoot OUS. So let's put this into action and see what the heck I'm babbling about here. Okay, so I can see way over here, this is just going to be a little chart to help you get started on how to name acids. So you can see it's hydrochloric acid. So I look at hydro and ic, so those are the prefix and the suffix for the acid, and I look at the root, which is chloric. Well, where did that come from? It came from chloride, so that would be my anion name. And I know that the anion charge is Cl minus 1. I can see that on my cation anion sheet. And the number of hydrogens required to reduce the acid. You need to keep in mind that hydrogen has a +1 charge. So if I have a -1 charge over here, I only require 1 hydrogen to balance it out. So my chemical formula is I always start with H. Well, how many? I just decided that it was 1, and then I add my anion, Cl, HCl. Okay, let's try this next one. So here I have the anion charge SO4. I look it up, and this is sulfate. And I really need to pay attention to the anion. And I got 2 hydrogens because I have a -2 charge. So I need 2 hydrogens to balance that out. So how do I write 2 hydrogens? I write the H with the subscript and then add my anion, SO4. Okay, well now I need to find the name. So I need to pay attention that the anion ends in "ate." So does the anion end in "ide"? Nope. Anion ends in "ate." So I'm going to take the root, which is sulf, and then put "ic" behind it, sulfuric acid. Now lots of people will just put sulfic because that's just dropping the ATE, and that is perfectly fine. I would never mark that wrong. But the proper root name is sulfuric acid. Okay, let's keep on going. Let's try another one. So here I have NOHNO2. So I'm gonna forget about the H right now. I'm gonna scribble that out there, sorry. And I'm gonna look at the NO2. So I look up the NO2, and that is, the name of that is nitrite. And I recognize that nitrite is NO2 with a -1 charge. And because it's -1, that means I need 1 hydrogen to balance that out. And I know you can't see that anymore, but let's see if I can erase that. You can see, look at that. You can see that I have one hydrogen, so it's HNO2. Okay, then I look at ite. So if I look back, it's nitrite. Okay, grab this here. So if I look at ite, the anion ends in ite. So now it's nitrous acid. So that would be the name of this acid because my anion ends in ITE. So nitrous acid. Okay, now let's try this one. So I have phosphate, it ends in 8. I look up phosphate and I can find it on my cation anion sheet that it's PO4 minus 2. Because I have a negative 2 charge, that means that I am going to have 2 hydrogen. And how do I write 2 hydrogen? I write H2 and then add my anion, SO4. And again, I'm looking at the suffix is ATE for my anion. So I look at my little chart over here. The anion ends in 8. So it is going to be phosphoric acid. Phosphoric acid, or phosphic if you just kind of abbreviate it. But the technical name would be phosphoric. Okay, one more here that we have in our chart is perbromic acid. So I can see that the per and the ic are there. So if I look back on my sheet here, it doesn't end in ID, or sorry, we're starting here. I don't have hydroic, I don't have root-ic, or OUS. I have a per-ic acid. So I look above and it comes from per-8. So mine is going to come from perbromate. So perbromate, when you look at these on your gold sheet, they are on the lower left-hand corner of the anion side. Sometimes you kind of cover it up by your arm there, so make sure you're looking underneath. So it's BrO4 minus 1. Because of the minus 1 charge, I have 1 hydrogen, and that's going to be HBrO4, perbromic acid. Okay, so now this chart is just a way to help you get started. We are not going to use this chart the whole time when we are naming acids. You're going to see them like these in 1 through 4, and you have to be able to reason it out what the name is, or the symbol. So in the first one, we're going to write down our symbol. So what am I going to take a look at? Well, I'm going to look that I have a root here, and it ends in ic, acid. So I will look on my chart, and I'll look for something that ends in ic. Well, here it is, root-ic. So my anion ends in 8. So instead of nitric, it came from nitrate. So then I would look on my gold sheet and say, okay, nitrate is NO3 minus 1. You don't have to write this down. You can put it in your head if you want. And I can look at this and say, okay, nitrate is NO3 minus 1. Because it has a minus 1, that tells me I need 1 hydrogen. I know all acids start with hydrogen. And then I simply add my anion. So if I try the next one, I would cross off my hydrogen, I would look up CN, and I would see that that is cyanide, ends in IDE, and when I have something that ends in IDE, that is when I put my hydro in front of it, put my root, which is cyanide, and it will be cyanic acid. So you can see I'm adding the hydro, I took off the IDE ending and put ic in front of after it. Acetic acid. So here's my root, and I have an ic right here. So that comes from an 8. So it'll be acetate is how you would say that. So it's acetate, and when I look that up, it's this big long one. C2H3O2 with a minus 1 charge. So again, I have this minus 1, so I know that I only need 1 hydrogen. Oh, sorry, this is getting a little bit messy here. HC2H3O2 is acetic acid, which all of you probably have at home, which common name is vinegar. Okay, the last example that I have here is I'm going to disregard the hydrogen. I'm going to look up SO3. And when you look up SO3, that's sulfite with an ITE ending. So that means my acid root is going to be with an OUS. So instead of sulfite, it's going to be sulfurous acid. All right, so that's how you name acids. You just have to take it apart, make sure you watch, take each little piece, and hopefully with this little trick of on your gold sheet with the naming acid compounds, that'll help you out. You also have this on the other gold sheet that I gave you with the if-then statements on the front side. It also has a little bit of what your roots are on there, and that might be helpful too. I'll make sure to point that out in class. All right, you guys have a wonderful night, and I will see you soon. All right, let me stop this here.